Okay, guys, so today we're going to talk about a new topic, a new lecture. This is our 7th lecture, I believe. We're going to talk about hypothesis testing applied to two related samples. Sometimes we call it related t-test or repeated t-test. They're actually talking about the same thing. You can use these two terms interchangeably. Okay, so let's do a quick recap about the two major tests we learned before. The first one is z-test. That is, when we want to compare a sample with a population, we know everything about these two things. We know about the sample's mean and SD. We also know about the population's mean and SD. And we want to compare whether the sample is coming from this population, we use a z-test. And when we still cannot do, let's say, we are gonna use this one sample t-test. That is, we want to compare our sample with the population, but we do not have the complete information about these two things. So what we know is sample's mean and the sample's SD. And we know population's mean, but we have no idea about the population's SD. So in this situation, we want to use this one sample t-test. And when are we going to use this repeated or related t-test, which we'll cover today? That is when we want to have when we have these two samples. We know these two samples mean, we know these two samples standard deviation. We want to compare whether these two samples, they have significantly different means or not. Okay, so whether these two samples are coming from the same population or not. Okay. So in this situation, we have no information at all about any data for any populations where these two samples come from, right? So the only information we've got here is the means for these two samples, the standard deviation for these two samples, okay? And the goal is for this test is we want to test whether these two samples, they are coming from the same population or not, okay? So let's go back to our lecture here. So for when we speak of kind of comparing two samples, we may have two situations or two scenarios. The first one is that we call it matched sample or related sample. So we have two sample of data set here. And in this situation, in this matched sample situation, these two samples of data are provided by the same participants. Okay, so each individual or each participant will provide two data points. And a very common situation or common design is this pre-test, intervention, and post-test. Okay, so let me give you a concrete example. So let's say I want to say a workout program at my gym will have any influence on my weight and on my body shape. Okay, so what I'm gonna do to test the effect is, well, first I want to do a pre-test. So before I get enrolled into this workout program in my gym, I want to, well, first weigh my weight, right? To have a kind of assess my weight. And then I'm gonna kind of get enrolled into this workout program, let's say for 1 month. And after it, I'm gonna kind of do a post test. I'm gonna kind of scale my weight again. I want to kind of measure my weight again. And then what I'm gonna do is to compare the results of my post test with my pre-test. Okay, so if there is a big change between the results of the post-test and the pre-test, I say that, oh, this workout program works. It's effective in terms of, helping me lose my weight or gaining my weight. Okay. So basically, this matched samples, the basic design is each individual, each participant will provide two data points. One is pre-test, the second one is post-test. And we are gonna do a kind of a weighting subject comparison. Okay, so I'm comparing my before and after data. That's the first situation we could have this two sample comparison. And second one, we call it independent samples. That is, we want to compare the data points between people. Okay, so the two samples of data are provided by two different groups of people. And I will use this a workout program in gym as an example to do a comparison. So in this situation, let's say if I want to do this independent samples, I'm gonna probably recruit 20 people, okay? And then I'm gonna randomly divide these 20 people into two groups. One is called the experiment group. The other one is called the control group, okay? So for these 10 people in this experiment group, I'm gonna ask them to get enrolled into this workout program in my gym. But for this control group, I'll just ask them to maintain their daily routine as before and do not get kind of enrolled in any workout program. Okay, and after 1 month, I'm gonna probably assess their weight, evaluate their body shape. At this time, I got two data sets. One data set is coming from this experiment group who have got enrolled into this workout program. And the other data set is coming from this control group who did not get enrolled into any workout program. So I want to compare these two data sets and see whether this experiment group have a better assessment, have a better evaluation in their body shape or in their weight compared with this control group. Okay, so the point here, essentially the point for these independent samples is we're gonna kind of divide people into two groups, and one group of people will receive some kind of stimuli or some intervention, and the other group they don't do anything. And then we want to compare these two groups. So we are basically doing something called between subject design. We want to compare the data between people. Okay, so it's not a before and after comparison. It's kind of individual by individual comparison. We want to make comparisons between one group to another group. Okay, so for our related t-test or repeated t-test, we're gonna look at these matched samples. And for these independent samples, we're gonna leave it to next class, okay? So again, today we're gonna talk about repeated or related t-test. And this test is specifically designed for this situation, this matched sample, where we want to do a before and after comparison. So we're gonna start with a concrete example for this matched sample and repeated t-test. So let's say I'm such a nerdy instructor and I really want to say that whether my statistics class would affect my students' anxiety levels, right? Essentially, I probably would expect that my stats class would make my students more anxious, okay? So what I'm going to do to answer this research question is, well, first I'm going to recruit all my 17 statistics students in my class, and I want to assess their anxiety levels at 2 points of time, okay? The first point of time I'm going to assess their anxiety level is before my class, before my statistic class, okay? We call it a pretest measurement. We use X to represent the results for this pretest. And then here comes to the torture. I'm gonna have this 1 semester, 16-week stats course, okay? And after this 16 weeks torture, I'm gonna have the post test. So I'm gonna measure my students, these 17 students, their anxiety level again. And this time I'm gonna use the letter Y to represent the results for this post-test measurement results. Okay. So again, we are kind of comparing, we are doing kind of a before and after comparison, and each student will provide 2 data points. One is pre-test, and second one is post-test. Okay, and here is the results for the pre-test. Okay, so we can see that we have 17 students here. And with the ID from 1 all the way up to 17. And this first row shows their anxiety level before my stats class. Okay, so we can see that most of them have a score about like 80 something, and we also got some like 70, and we also got 94. This students is really showing high level of anxiety. Okay, and here the second row here, we have the people's post-test measurement results after my stats class. Okay, still 17 data points, and we can see that on a rough look, we can see that students, there is a general increase regarding these 17 students' anxiety level. The first student, his anxiety level has increased from 83.8 to 95.2. And we can see this student, his anxiety level has hit 101.6. Okay. We also see some students, they has a decrease in their anxiety level, right, from 81 to 77. And here I also calculated the mean and the standard deviation for each test. Okay, so we can see that before this my stats class, the pre-test measurement, these 17 students have a mean of anxiety level of 83.23, and SD is 5.02. And for this after test, this post-test measurement, these 17 students, they have an average of anxiety level, which is 90.49, and a standard deviation is 8.48. So apparently, by looking at the means, we can see there is a 7 units increase here, right? So 7.26. Okay. So my question here is, this increase of 7.26, is it a true difference or is it a sampling error? It's something kind of due to chance. Okay, so here is a question. We have these 17 students, and we do this pre-test and we do this post-test. And comparing the means for the pre-test and the post-test, we see a 7.26 units of difference or increase. So we want to kind of run some tests and answer the question whether this 7.26 is a true difference or is a significant difference, or it's just a kind of a sampling error. It's purely due to chance. That's our research question we want to address.